Welcome to the world of trigonometry. Trigonometry is a branch of mathematics that deals with the relationship between the angles and sides of triangles, especially right-angled triangles. It's a fundamental topic that helps us understand shapes, patterns, and even the movement of waves. Whether you're looking at the height of a building or the distance across a river, trigonometry provides the tools to solve these problems. In this video, we'll break down the basics, explore key concepts, and show you how trigonometry is used in real life. Let's start by understanding what trigonometry really means and why it's so important. Trigonometry has a rich history that dates back thousands of years. Ancient civilizations like the Babylonians and Egyptians used early forms of trigonometry for astronomy and construction. The Greeks, especially Hipparchus, are credited with formalizing trigonometric concepts. Over time, these ideas spread across the world, influencing mathematics, science, and engineering. Today, trigonometry is a universal language for solving problems involving angles and distances. Understanding its origins helps us appreciate how far this field has come and its lasting impact on our daily lives. The heart of trigonometry lies the triangle, especially the right-angled triangle. Triangles are simple yet powerful shapes that appear everywhere in nature and design. By studying the properties of triangles, we can unlock a world of mathematical relationships. The right-angled triangle, with one angle exactly 90 degrees, is particularly important because it allows us to define the basic trigonometric ratios. Throughout this video, we'll focus on how triangles form the foundation for all trigonometric concepts and calculations. Right-angled triangle is a triangle where one of the angles measures exactly 90 degrees. This special triangle is the starting point for most trigonometric concepts. The side opposite the right angle is called the hypotenuse, while the other two sides are known as the adjacent and opposite sides, depending on the angle you're focusing on. Understanding the structure of right-angled triangles is crucial for applying trigonometric ratios and solving real-world problems. Let's get familiar with the names of the sides in a right-angled triangle. The hypotenuse is always the longest side and is opposite the right angle. The side next to the angle you're working with is called the adjacent side, and the side opposite that angle is, fittingly, the opposite side. These names are essential because they help us define the trigonometric ratios that you'll use throughout your studies. Trigonometry revolves around three main ratios: sine, cosine, and tangent. These ratios compare the lengths of different sides of a right-angled triangle. Sine is the ratio of the opposite side to the hypotenuse, cosine is the adjacent side to the hypotenuse, and tangent is the opposite side to the adjacent side. These ratios are the building blocks for solving countless problems in mathematics, physics, and engineering. Sine ratio, often written as sin theta, is one of the most important concepts in trigonometry. It's defined as the length of the side opposite the angle divided by the length of the hypotenuse. This simple ratio allows us to find unknown sides or angles in a right-angled triangle. Sine is used in everything from calculating heights to analyzing waves in physics. Next up is the cosine ratio, written as cos theta. Cosine compares the length of the adjacent side to the hypotenuse. Like sine, cosine is a powerful tool for solving triangles and is widely used in science and engineering. Whether you're working with angles in a building or analyzing forces, cosine helps you break down complex problems into manageable parts. Tangent ratio, written as tan theta, is the third key trigonometric ratio. It's defined as the length of the opposite side divided by the length of the adjacent side. Tangent is especially useful when you know two sides of a triangle and need to find an angle. It's also used in navigation, surveying, and even in computer graphics. Popular way to remember the trigonometric ratios is the acronym SOH-CAH-TOA. SO stands for sine equals opposite over hypotenuse, CAH for cosine equals adjacent over hypotenuse, and TOA for tangent equals opposite over adjacent. This simple memory trick helps students recall the formulas quickly and accurately, making problem solving much easier. Modern calculators make trigonometry much more accessible. With just a few button presses, you can find the sine, cosine, or tangent of any angle. Make sure your calculator is set to the correct mode, degrees or radians depending on the problem. Calculators also help you solve for unknown sides or angles quickly, saving time and reducing errors. Angles can be measured in degrees or radians. A full circle is 360 degrees or 2 pi radians. Most basic trigonometry problems use degrees, but radians are common in higher mathematics and physics. Understanding the relationship between degrees and radians is important for switching between different types of problems and for using calculators correctly. Convert degrees to radians, multiply by pi/180. To convert radians to degrees, multiply by 180/pi. This conversion is essential when working with trigonometric functions in different contexts, especially in science and engineering. Practice converting between these units to become comfortable with both systems. Unit circle is a circle with a radius of 1, centered at the origin of a coordinate plane. It's a powerful tool for visualizing trigonometric functions and understanding how angles and ratios work together. The unit circle helps you see how sine, cosine, and tangent values repeat in cycles, which is especially useful in advanced mathematics. In the unit circle, the x-coordinate of a point represents the cosine of the angle, while the y-coordinate represents the sine. As you move around the circle, these values change smoothly, creating the familiar wave patterns seen in graphs of sine and cosine. This connection makes it easier to understand how trigonometric functions behave and why they're so useful in modeling periodic phenomena. When you graph the sine and cosine functions, you get smooth, repeating waves. These graphs show how the values of sine and cosine change as the angle increases. The patterns are periodic, meaning they repeat at regular intervals. Understanding these graphs is key for studying waves, sound, and even electrical signals. Tangent function has a unique graph compared to sine and cosine. It features repeating vertical asymptotes where the function is undefined and the values increase or decrease rapidly near these points. The tangent graph is also periodic but with a different pattern. Recognizing these features helps you understand where tangent is useful and where it can't be applied. Sometimes you need to find an angle when you know the sides of a triangle. That's where inverse trigonometric functions come in. These functions, arcsine, arcos, and arctan, let you work backwards from the ratios to the angles. They're essential for solving triangles and for applications in navigation, engineering, and physics. Find an unknown angle in a right-angled triangle. Use the inverse trigonometric functions on your calculator. For example, if you know the opposite and hypotenuse, use arcsine. If you know the adjacent and hypotenuse, use arcos. And if you know the opposite and adjacent, use arctan. These tools make it easy to solve for any angle quickly and accurately. Pythagorean theorem is a cornerstone of trigonometry. It states that in a right-angled triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. This relationship allows you to find missing sides and is the basis for many trigonometric calculations. Mastering this theorem is essential for success in trigonometry. Let's see the Pythagorean theorem in action. Suppose you know the lengths of two sides of a right-angled triangle. You can use the theorem to find the third side by rearranging the formula. This method is widely used in construction, navigation, and even computer graphics to calculate distances and ensure accuracy. Triangles have special properties that make calculations easier. The 45-40, 590, and 30-60-90 triangles have predictable side ratios, which can save time when solving problems. Recognizing these special triangles helps you apply trigonometric concepts more efficiently and with greater confidence. Trigonometric identities are equations that are always true for any angle. These include the Pythagorean identity, the sum and difference formulas, and double angle formulas. Identities help simplify complex expressions and solve challenging problems, making them a powerful tool in your mathematical toolkit. One of the most important trigonometric identities is the Pythagorean identity. Sin 2 theta plus cos 2 theta equals 1. This equation is true for any angle and is derived from the unit circle. It's used to simplify expressions and solve equations involving sine and cosine. The sum and difference formulas allow you to find the sine, cosine, or tangent of the sum or difference of two angles. These formulas are especially useful in advanced trigonometry and calculus, helping you break down complex problems into simpler parts. Double angle and half angle formulas let you find the sine, cosine, or tangent of twice or half an angle. These formulas are handy for simplifying expressions and solving trigonometric equations, especially in calculus and physics. The law of sines is a powerful tool for solving triangles that aren't right-angled. It relates the ratios of the sides of a triangle to the sines of their opposite angles. This law is especially useful in navigation, astronomy, and surveying. To use the law of sines, set up a proportion comparing the sides and the sines of their opposite angles. This method allows you to solve for unknown sides or angles in any triangle, not just right-angled ones. It's a versatile tool for many real-world applications. The law of cosines is another essential formula for solving triangles. It relates the lengths of the sides of a triangle to the cosine of one of its angles. This law is especially helpful when you know two sides and the included angle or all three sides. To use the law of cosines, plug the known values into the formula and solve for the unknown side or angle. This law is particularly useful in navigation, engineering, and physics, where you often deal with non-right triangles. Trigonometry isn't just for the classroom. It's used in architecture, engineering, astronomy, and even music. From designing buildings to navigating ships, trigonometry helps solve practical problems every day. Understanding its real-life applications makes learning trigonometry more meaningful and exciting. Builders and engineers use trigonometry to calculate heights, distances, and angles when constructing buildings, bridges, and roads. Accurate measurements are crucial for safety and stability, and trigonometry provides the tools to ensure everything fits together perfectly. Navigators use trigonometry to chart courses across the sea or sky. By measuring angles and distances, they can determine their exact position and plot the safest route. Trigonometry has been vital for explorers and travelers throughout history. Astronomers use trigonometry to calculate the distances between stars, planets, and galaxies. By measuring angles from Earth, they can estimate how far away celestial objects are, helping us understand the vastness of the universe. Even music relies on trigonometry. Sound waves are modeled using sine and cosine functions, allowing engineers to design instruments and audio equipment. Trigonometry helps us understand how sound travels and how to create beautiful music. Artists use trigonometry to create perspective and proportion in their work. By understanding angles and ratios, they can make their drawings and paintings more realistic. Trigonometry bridges the gap between creativity and mathematics. Engineers use trigonometry to analyze forces, design structures, and solve technical problems. Whether it's building a bridge or designing a machine, trigonometry ensures everything works as intended and meets safety standards. Physics relies heavily on trigonometry to describe motion, waves, and forces. From calculating projectile paths to analyzing light and sound, trigonometry helps physicists make sense of the natural world. Computer graphics use trigonometry to create realistic images and animations. By calculating angles and distances, programmers can simulate movement, lighting, and perspective, bringing digital worlds to life. Medical professionals use trigonometry in imaging techniques like CT scans and ultrasounds. By measuring angles and distances inside the body, doctors can diagnose and treat patients more effectively. Athletes and coaches use trigonometry to analyze movements, optimize performance, and design training programs. From calculating the best angle for a shot to measuring distances on the field, trigonometry plays a key role in sports science. Architects use trigonometry to design buildings, bridges, and other structures. By calculating angles and dimensions, they ensure that their designs are both beautiful and structurally sound. Pilots and air traffic controllers use trigonometry to navigate the skies. By measuring angles and distances, they can plot safe flight paths and avoid obstacles, ensuring safe and efficient travel. You might not realize it, but trigonometry is part of your daily life. From measuring the height of a tree to figuring out the best angle to lean a ladder, trigonometry helps you solve practical problems quickly and accurately. You've covered the basics of trigonometry, from right-angled triangles and trigonometric ratios to real-world applications. Trigonometry is a powerful tool that opens doors to many fields, from science and engineering to art and music. Keep practicing, explore more advanced topics, and you'll find that trigonometry becomes an invaluable part of your mathematical journey.